Welcome to the Zojo webinar. I'm Paul Lefevre, the Zojo Developer Evangelist. And our topic this time is Raspberry Pi and Zojo. So first, just a very brief overview about the Raspberry Pi itself. This was introduced in 2012, and it is what is referred to as a single board computer. So this is a tiny little computer, about the size of a deck of cards, really. But it's a fully functioning computer, very small. Also, cheap, only about $35 for the raw board that you see here, not including cases and other things. It's low power, so that allows it to be used in places that otherwise you might need an actual power outlet. And the big difference is, though, it is ARM-based, so it's not an x86 CPU that can run, standard Windows or Mac stuff or Linux distributions. It's ARM-based. It does run Linux, but it's an ARM Linux, so that's its big difference. There have been over 19 million of these things sold. These are the latest numbers I could find as of this month. And so it's a popular little gadget. And a few years ago, Zojo added support for it. But what is Zojo? Well, Zojo is a lot of things. It's a programming language. It's a framework for making your own apps that allows you to make all types of apps. And it is an integrated development environment. So you have essentially a single app that you use to make your own apps, design the apps, write the code, all that stuff, test it out. And you can run Zojo on your favorite operating system. It does require a standard x86 computer, but it can run on Windows, Mac, or Linux. And with Zojo, you can develop faster. Having everything all in one, a single tool that's pretty easy to use, lets you make your apps more easily. And Zojo itself is actually free to use. You can use it to develop and design and run and test your apps without having to pay for anything. You can download it for free and do all that. And you can buy licenses when you're ready to deploy your apps. And I'll talk a little bit more later about that in relation to Raspberry Pi. And in case you've never heard of Zojo, well, we've been around since 1998, so 20 years this year. And it's gone by a few different names, Real Basic, Real Studio, now it's Zojo. And we kind of like that name, so I think we're going to be sticking with it for a while. So what can you do with a Raspberry Pi? Well, as I mentioned earlier, it pretty much is a full-featured computer, so you can kind of do whatever you want with it. The big thing to remember is it's running an ARM CPU. Even though it is going to have Linux, that does limit some of the apps that you might be able to install and run on the thing. But you can, of course, run apps on that. You can run Office products on it. It comes with a few apps built into the standard default Pi operating system called Raspbian. You can build hardware projects that connect to the Pi using its GPIO port, which I'll briefly show you in a moment. And that's kind of fun. That's probably what a lot of people use the Pi to do, is small or even not so small electronics types projects. You can use a Pi as a small web server in your house for low usage tasks. People can use Raspberry Pis as a virtual private network for added security when you're connecting to networks outside of your home. But there are some limitations with a Pi. First of all, it does not have a hard disk. It uses SD cards for storage. So that means your I/O is going to be a little slower than you'll be used to with, a full-featured computer. And the Pi has limited RAM. I believe right now it's 1 gigabyte is all that it comes with. You can't add more. Even the latest version that just came out, I think, still has the same amount of RAM. So that's probably the biggest concern to work with, is you don't have a lot of memory to use on the Pi. And I say low performance just in relation to, full-featured computers. The Pi is actually pretty speedy. It's got a multi-core CPU in it, but it doesn't have a fan. It doesn't want to run real hot, so if you're really pushing that Pi, it's going to put out quite a bit of heat. You don't want to melt the thing, so you're going to have to make sure it's properly mounted in a case and whatnot. But so it's not really designed for, high-performance CPU usage, but, it's not slow in and of itself. So what about the Pi hardware? Well, this is the board itself. And this is the raw Pi board. This is the thing you get when you find one and buy one for $35. And it's got a few things here I just want to call out. So the GPIO pins, that's the general purpose input-output pins, allow you to connect things up to it, circuits, electronic projects, that sort of thing. And the pins do various things. Some of them provide power, some of them are ground, some of them are signals that you can turn on and off to track or control other things. And you can all control this stuff programmatically. The Pi has 4 USB ports. Obviously, that's super handy for connecting things like keyboards and mice and other peripherals. There's an Ethernet port. So if you have your Pi, mounted somewhere in your house and you say you do want to use it as a server, if you have access to Ethernet, you can plug it right in. It also has Wi-Fi. There is an audio-visual port. This is just a standard 1/8 inch headphone jack type thing that can be used to play audio, primarily is what I've used it for. There is an HDMI port for connecting this up to a display. So this can actually just plug right into a television, kind of like old school people used to do with their old Commodores and Ataris back in the 80s. Power comes from a micro USB port, and that's only for power. That it doesn't provide data or anything like that. There's a slot underneath the board for the micro SD card, and you just get one of those in whatever size you think is going to work for what you're doing, and you just slip it in the slot there, and you can install the operating system on it, and it'll boot right from it. And then on the top, there's a couple proprietary ports on the Pi for hooking up a display. This is more of like a built-in LCD or maybe a touch display. They can plug right in there. And there's also a port for a camera as well. And I got a couple notes here from Edwin in the Q&A that I'll bring up while I'm on this page as well. He notes, and I'm not specifically going to mention them, but in addition to the Raspberry Pi, there are lots of other single board computers that are largely compatible with it, and some offer additional features. And Edwin's noting that there are some that offer support for SATA, SATA hard drive connections, and USB 3 as well, to give you more I/O performance if you need it. I don't know specifically what those are, but if you do search around, I'm sure you can find stuff like that. And Edwin also thinks the SD card capacity might max out at 64 gigabytes. I do not know offhand. I'm running 32 gigabyte card on mine at the moment, and I don't know if they have a built-in limitation. So where can you get your Raspberry Pi? Well, if you can use it with Zojo, I just want to point out which models you'll want to make sure you stick with. The oldest one that will work is the Raspberry Pi 2. This one came out a few years ago. But the one you probably want to stick with is one of the Raspberry Pi 3 models. The Pi 3 came out, I think it was last year maybe, but just a few weeks ago, the Pi 3B Plus was just announced, and I believe is available for purchase. I haven't picked one up yet myself. But as is typical, it's a little speedier, so that's always good. Speed is always good. And of course, these are all fully compatible with Zojo apps. Here in the US, Adafruit has a lot of Pi-related things, so that's a good website to check out. You can buy the Pi from there, and then accessories and peripherals and stuff like that. It's a fun site to start going through. Careful, you could end up spending a lot of time going through all the neat little things they have there. And then KanaKit sells kind of Pis in kit form, and kits are nice because you get everything you need. You don't have to search out all the pieces individually. So like I said, the Pi itself is really just the board, but that doesn't work unless you have power for it. And you have to make sure you're providing enough power. So you need a micro USB power cord that can provide enough power. You may want a heat sink to attach to the top of the CPU if you are pushing the processor a little bit and want to make sure it doesn't overheat. And a little case is always cool. So kits sometimes can be a better way to get a Pi. Might come with a card. Maybe it's cheaper if you bought all the pieces individually, but I think kits are great. And you don't have to worry about USB Wi-Fi anymore in the Pi 3s. That's built in, but the Pi 2 did not have Wi-Fi. So just on a high level, when you get your Pi, if you buy a kit, you probably won't even have to do this because odds are the SD card will probably already be configured. But the first thing you want to do is install Raspbian on the SD card itself. That's the Linux operating system. And then for use with Zojo, you'll boot up the Pi, log into the thing. I did this the first time. I just plugged it into the TV set that I have in the living room with a keyboard. Use that as its setup. And then I wanted to configure the VNC client that's on there, or the server, I guess it is. That's the virtual network computing, I guess that is. But essentially, it allows you to connect to your Pi remotely, which is going to be super helpful when you're working with Zojo. And then on the Pi, you can install the Zojo remote debugger, the one for Linux ARM, which you can get from any Zojo download. And then you create your apps using Zojo on your primary computer, your Mac or Windows or Linux x86 computer. And using the remote debugger, you can then tell Zojo to build and run the app on the Pi itself. And using the VNC, you can just bring up a window that shows you what's on the Pi and work with it that way. So it's super handy. And you don't need a dedicated display for the Pi that way. So once you've configured it, you can unhook it from your TV set and move it somewhere else. I keep mine in my office right next to my Mac. So what Zojo features are available when you use it with Raspberry Pi? Well, if you're not familiar with Zojo, the first thing to know is Zojo makes native compiled apps. So Zojo is not a scripting language. It doesn't interpret your code as you're running it or anything like that. It builds actual apps that you run on the Pi, the same as any other app. Zojo can make a wide variety of apps. It can make desktop apps, it can make web apps, and it can make console apps. And depending on what you need to do on your Pi, any or one or some of those may be useful. A desktop app is just one that has a user interface, like a mail client or something like that. A web app is going to run in a web browser. And then a console app just means a text app. So you don't need to have any sort of UI running at all. If you are doing UI, there are a few built-in UI controls that Zojo gives you to play with. Buttons, of course, segmented controls, toolbars, menus, checkboxes, text input fields, canvas control for drawing whatever you want to draw, graphics or whatnot, labels, listbox grid for displaying data. All kinds of controls that you can use to design the user interface of any apps you want to make for your Pi. In addition to what Zojo has built in, lots of third-party controls and plugins are also compatible with Pi apps. So you can even add more features to Zojo. Zojo has a built-in SQLite database, which works great on the Pi, and having databases are pretty common for some types of apps, so it's good to have one that you can access and use easily. And we also have an open source library that you can use to access the GPIO functionality of the Pi, and this provides, it's a library, so it gives you a set of commands that let you control things that are hooked up to the GPIO pins. So I'll reiterate the overall Zojo process. You create your project, desktop, console, or web. In Zojo itself, you're going to go to the Linux build setting and change the architecture to ARM 32-bit, and that allows it to run on the Pi. And then you'll design your app. If it's a UI app, you'll design the app layout. If not, you'll just write some code, but either way, you're going to be writing code at some point. And when you are writing the code, which we'll look at in a moment, Zojo code is very similar to Visual Basic in how it looks, and the object model for its object-oriented programming language is similar to Java and Python. So a nice mixture there. And if you're familiar with any of those things, Zojo should be pretty recognizable to you. And then you do the usual software development process of running, testing, debugging, compiling, distributing when you think you have something that's done. So let's switch over to Zojo and take a look at a few things and run them on the Pi. So first here I have VNC running. This is the viewer app. So I'm going to double click here to connect it to my Pi, which is on my desk here in front of me. And now I can see my Pi screen right in its own window. Super handy. This is why developers like giant screens or multiple displays, so that you can have stuff like this all over the place, making it easy to see. So right now, the only things I'm running on the Pi are the Zojo remote debugger and a terminal window. So the remote debugger here, I just copied from a Zojo installation and ran it here, and it tells me the IP address. And so that's handy. So now I can go over to Zojo. This is here running on my Mac. So this is Zojo running on my Mac right now. And I have a project open here. This is a simple, very simple little game. And what it will do is it'll have some Zojo logos fall from the top of the screen. And if you click on them, you get a point. It's not a very hard game. But what I can do right here, and if you can see what Zojo code looks like, you can see some of the layout. This is a very simple game, so all it has for a layout is a giant canvas on the main window, which has code to draw things. And this example is included in the Pi book, the free Pi book that we have that shows you how to do Zojo programming for the Pi. I'll have links for that a little bit later. But here in the project menu, I can pick run remotely and tell it to run on the Raspberry Pi, because I've already done the setup to add an entry for the Pi remote debugger that I've already installed there. So when I click this, Zojo's going to compile the app as it normally would. And then when it's done with that, it is going to transfer it over to the Pi. So I can bring up my Pi display here, and when it's done transferring, it'll just pop up on the screen, and then I can use it and interact with it. So you can see it's running here. As I click on Falling Zojos, my score increases. That's pretty much the extent of the game, just to show off some simple graphics capabilities. And when I quit the app, you can see in the background here, the Zojo itself that's running on my Mac went back to what we were looking at before. And because that's called the remote debugger, it allows me to test. I can set breakpoints by clicking here, and then as it walks through the code, it'll stop here so you can review things to see how it's working. So it makes it pretty easy to work and do your development. So that is one example of a little bit of graphics and stuff. I'm going to next try this app here. This is a app we also run on the Pi. This plays some music through the Pi's output. And here I can tell it the folder that I have some music in. And you can hear my music choices. I forgot how long the intro is on this. So you get a little jukebox of the lovely 80s music that I listen to all the time. But you see, you still can, do media and other things on the Pi, so that is fun. Hopefully I don't have too much clips there that YouTube is going to flag me for copyright or anything like that. And we can go back to Zojo. And those were two desktop apps, but I mentioned earlier Zojo can make other kinds of apps. And I have here a web app, MathFacts. And I'm going to show this a little differently. I'm actually going to run this on the Mac here, but we're going to connect to it from the Pi's browser. So MathFacts is just a simple little app that something like a math teacher could use. And it just automatically generates some math problems and lets the students type the answers, and it marks them green or red if you answer them wrong. So little simple app there. But if I go over to my Pi, I can open the web browser on here. And you can notice slight delays when I click on things on my Pi. I still have an older Pi 2, and I haven't yet ordered my Pi 3, which I would like to do because it is definitely speedier than a Pi 2. So here I entered the address of the web app that's running on my Mac. The Pi is running on the same local network here at my office that my Mac is, so they can connect to each other. And because the web app is running on the Mac, I can connect to it from a browser anywhere that it is accessible. So here, this is the address, and the app works the same on the Pi, marking things green or red if they are incorrect. And you can see a page like this has just a simple web app with a few styles to highlight controls, green or red, based on whether the associated math problem was answered correctly. You could also do the reverse and actually build this app for the Pi and then run the web app on the Pi and then connect to it from a Mac. So in that case, you'd kind of be using the Raspberry Pi as a simple little web server, and that direction also works. All right, and the last little app I want to show off here is a console app. And this is just a text adventure kind of app. So it doesn't use any UI, it doesn't have a layout, it's going to run in the terminal. And so there's not a lot to look at when you're looking at this, because there's no pretty UI to click on or windows or web page layouts to look at. You just get clicking on methods and looking at source code. So you can see this sort of thing, lots of commands to output the instructions for the game, configuring the maps for the world that we're going to be in. And I already have built this and transferred it over to the Pi, so I can just run it here. And if you've ever played any 80s text adventures, you can see how this goes. And I can type commands. And the whole goal of this very ridiculously simple game is to wander around a house, which is actually modeled after my house, and look at things to see if you can find where the Seltzer the cat might happen to be hiding. And look, in this case, he was hiding in the cat condo downstairs. And it's just a random thing. The score is largely useless since you have to go into each room and check, and only way you get a low score is if you guess right. But it kind of gives you an idea for how you might set up such a game by having classes for the various rooms and things like that. All right. So those are some of the things you can make using Zojo. Let's switch back here. I have a few more things to cover, and then I'll take some questions. So I mentioned earlier, we have a Programming the Raspberry Pi book. It has 19 chapters. There's about 85 pages with multiple sample projects, many of which I've shown you just now that are in the book. And you can grab that book at the Zojo Dev Center, developer.zojo.com/pibook. You can head over there, grab the book. You can read it online, and I think there's a PDF as well that you can click to download. I'll show you something in a moment with the GPIO library, but I want to point out where that is and what that is. The GPIO library is a free open source library, and it maps to the Wiring Pi library system that provides access to the GPIO pins. So GPIO gives you access for pin control. It has some support for the Softtone library for controlling little buzzers and speakers. It has some built-in classes for handling servos, making them move around and whatnot. It has some classes for outputting information on an LCD screen. That's like a calculator type screen. And it also has soft PWM. That's I think it's pulse width modulation commands for some of the pins, and that's handled through software. So there's some built-in support for that. And you can grab the GPIO library and use it in your Zojo Pi projects. It's on GitHub. As I mentioned, it's open source. GitHub.com/Zojo and then GPIO. So you should probably take a look at Zojo if you haven't already. There's over 200,000 people around the world that are using it. And as we like to tell people, Zojo is not just for Pi apps. So unlike some of the things you might find pre-installed on your Pi that maybe are cool but aren't of much use elsewhere, Zojo lets you make apps for Windows, for Mac OS, for Linux. You can even make iOS apps, so mobile apps. And Android is planned for this year as well. So that will cover quite a bit of devices that are out there. And because of that, Zojo kind of lets you develop faster because you only have to learn one thing to make lots of things. I mentioned Zojo is free to use for your development purposes. You can just download it and start writing code and testing it and all that fun stuff. And speaking of fun, Zojo is kind of fun. If you've been developing for a long time, you can find yourself getting annoyed or frustrated, and people tend to like coding in Zojo. It's a fun way to make apps and program, and programming should be fun. That's how I got into it. And Zojo is also a great way to learn because it's pretty simple when compared to some of the stuff you find out there now. Compared to complex things like Java, where you have to manage a bajillion source files and maybe use really complicated tools to work with it. Zojo is a lot simpler to get started with. And of course, you can profit from using Zojo by actually making apps for other people and charging them, or even making apps and selling them. So you can get started today with Zojo. You can head over to our site and download it, zojo.com/download. And as of Pi Day this year, so that was just a couple weeks ago, March 14th, Pi console licenses of Zojo are now free. So you can simply email hello@zojo.com and request your free console license for Zojo Pi, and you'll get a free license. So this will allow you to build text-based apps for your Pi without even having to purchase a license. And that's because we want people to play with their Pi and learn how to program, and then eventually say, you know what, love Zojo so much, we're going to buy another license because we want to use it for lots of things. And I'm just going to go through the resources here. I've mentioned a few of these in various places. Of course, the download area where you can download Zojo, grab it for your favorite operating system. The book is available at the Dev Center. We have another book if you're actually totally new to programming and want to maybe start at the beginning. You can go to zojo.com/learn and grab a book there. It's not really Pi specific, but you can certainly use the examples on the Pi as well. The Zojo user community is at forum.zojo.com, a great place to ask questions about Zojo in general and using Zojo with a Pi. The GPIO library is available on GitHub. And of course, the Dev Center is kind of where all this stuff is hooked up together, developer.zojo.com. And there's also additional Pi information in the user guide that you can take a peek at. And for those of you that do want to purchase a more advanced license of Zojo, you can use the code NEW2018 to save 10%. And that will be useful if you wanted to buy a license to let you make desktop apps on your Mac in addition to desktop apps on the Pi or whatever. We offer a wide variety of licenses. And one more thing I wanted to show you today. Something we've taken to starting calling Zojo Dojo right now, but that's kind of a silly name. I don't know if it'll stick. But this is a little app that runs on the Pi. And it lets you make simple programs. It's an alpha. This is like alpha 111 or 001. That's how they do it these days. And you can download that from here. I'm going to show this to you in a moment. But this is a neat little thing for maybe people that don't want to have or don't have or don't want to run Zojo itself, because you need a separate computer for that. Zojo itself doesn't run on the Pi. This little app does run on the Pi and lets you make simple programs using most of the Zojo language. Or at least you can use the Zojo language, not a lot of its framework, just a few commands here or there. And all the links that I've gone through that maybe you haven't memorized or written down yet will be in the show notes, and the recording of this will appear within the next day. So let's switch back to our Pi here. And I've installed this so that it shows up in the programming menu here. And essentially, it's just a little code editor where you can write code. It comes with a few example scripts so you can get a feel for what some of the syntax looks like. So this here is actually using the GPIO. And this little program will play the Super Mario tune using a tiny little speaker I have wired up to the GPIO. Well, there you go. Part of the tune. I don't have all the notes. I'm not that musically inclined. So if you're totally new to programming and you just have a Pi, maybe hooked up to your TV, you could install Zojo Dojo on it and go through, some little programming. Reminds me a little bit of my glory days back in the early 80s with an Atari hitched up. And you can write some code, see some text output. This is implementing the algorithm for a very simple bubble sort. That's one of the first algorithms you might learn. And you can even do some simple drawing. This is an implementation of something I saw on the internet. It was a simple Commodore 64 program that drew this pattern that looks like a maze, but isn't actually a maze. It's more of just a pattern, which I thought was cool. So I just wanted to show people that. Make that available for people to play around with. I expect we're going to make this Zojo Dojo thing an open source thing, so you should expect it on GitHub with maybe a little bit of documentation, which there isn't really much about right now other than the example programs. But, play around with that. Love to get your feedback on it. All right, so I'm going to wrap things up here and remind people how you can reach me. Email, of course, paul@zojo.com. Twitter, I love Twitter. So you can reach me at @LaFever and the company account @Zojo as well. And I'll remind you, the code NEW2018 will save you 10% when you want to get your more advanced Zojo license, which you totally want to do because you can do so much with Zojo. All right, well, I want to thank everyone for attending the Zojo and Raspberry Pi webinar. I can't wait to see all the cool Pi type stuff that people are going to make using Zojo. And again, if you have questions, reach me via email or on Twitter. Have a great day, everyone.